Section 6.1, Day 2, we are going to do the converse to Pythagorean theorem. Basically, it is just if we use Pythagorean theorem, can we defend if the figure is a triangle or not? So to start out, the triangle inequality theorem seems confusing, but it's not too bad. If we plan to make a triangle, the sum of the two small sides must be greater than the longest side in order to have all of the vertices connect. So I'm going to label some information. I'm going to call the side opposite capital A or angle A little a, the side opposite angle B little b, and the side opposite capital C angle little c. So what this is saying is, even though the picture looks like side B is the longest, in order to make a triangle, the two smallest sides, so let's say the two smallest sides are A and C, A plus C has to be bigger than side B. But you could do this in various different ways. You're basically taking two of the sides of the triangle, and those two sides added up must be bigger than the third side. So I'm going to write all combinations of this. I could also write A plus B greater than C, and B plus C would be greater than A. So, for example, let's look at our first example. Can segments with lengths of 8 and 3 and 5 form a triangle? So it says the sum of the two sides, so basically the two smaller sides, must be greater than the longest side. So what I'm going to do is I'm just going to add 3 plus 5. Is that greater than 8? That is not greater than 8. This is false. It is equal to 8. So therefore, these three side lengths cannot create a triangle. It would kind of come short. It would look something like that. So this is false. Therefore, we would say that this is not a triangle. So you can try all different combinations, but as soon as you find one that's false, then it is not a triangle. So let's now look at part B, can segments with 1.8, 3.5, and 5.2. I always take the two smaller sides. I'm going to do 1.8 plus 3.5. Is that greater than 5.2 is the question. Using a calculator, 1.8 plus 3.5, 1.8 plus 3.5 gives us a sum of 5.3. And 5.3 is, yes, indeed, greater than 5.2. This is true. So my response to this would be, yes, it is a triangle. And then also part C, it says, can segments of 6.1, 11.3, and 4.2, just be careful because sometimes they're out of order. So I'm going to put 4.2 plus 6.1, is that greater than 11.3? And when I do 4.2 plus 6.1, 4.2 plus 6.1, I'm going to get 10.3. This will be 10.3, and 10.3 is not a greater than 11.3. This is false. And so we would say that this is not a triangle. If it is a triangle, we can move on to the next question. So in part B, because it is a triangle, we can then classify the triangle. So we would classify a triangle. So if a triangle, then we can use this theorem. And this theorem uses Pythagorean theorem. In the first picture on the far left, if we know that the sum of the squares of A and B is greater than C, then the triangle will be acute. If we know that the sum of the squares of A and B is equal to C squared, then it is a right triangle. We'll just look at the picture. And then lastly, if the sum of the two squares of A and B is less than C squared, then it is an obtuse triangle. I think the best way to kind of look at this, because it's kind of confusing with the inequalities, is we refer to this as greater than as we read it left to right. Some people might call that the alligator or the Pac-Man. And because the A squared is over here, it's eating the A squared sum of terms. So the a squared goes with acute. Let's see how this works. Let's go to example 2 on the back. And we don't have any triangle drawn. First thing you need to do is you need to verify that it is a triangle. So I'm going to put verify that it is a triangle. 3 times square root of 61 on my calculator is about 23.43. So I need to understand it that way just so I can compare. So if I do the 2 smaller sides, 15 plus 17.2, yes, indeed, that is greater than 23.43. So I'm going to say check, it is a triangle. Now that I verified it, because 15 plus 7.2 is greater than 23.43, now what I can do is I can classify. So yes, it's a triangle, now I'm going to classify. Now I square it. So I'm going to do 15 squared plus 17.2 squared, and I'm going to put a box, because I don't know. Then I'm going to do 3 square root of 61 squared. And when you do this, you will get 225 using a calculator. It is going to be crucial that you come equipped with a calculator to class every day. A lot of these calculations are very challenging without a calculator. You can even put this expression using the parentheses into your calculator, just as you see it. Open parentheses, and I'm going to show you. So open parentheses 3, square root 61. Then I'm going to close parentheses. That's going to be important. Exiting out of the radical, closing parentheses, and then squaring. I will get 549. Going back to this, this is 549. And then I'm going to continue by adding on the left side. 225 plus 295.84 is 520.84. We're going to compare and fill in the box. That is definitely less than 549. So remember, we already verified. And verification was just that the 2 smaller sides, sum is bigger than the third side. Now we move on to squared for classifying. So because it's less than, I'm going to put my rules. I'm going to just flash back to the rules. If it is less than, notice there's a less than right here, then the type of triangle we have is considered obtuse. So this is an obtuse triangle. Okay, let's go on to the you try nows. I am going to do problem number 2. So first thing I'm going to do is I'm going to verify that my 3 numbers, and again, I'm going to use my calculator to figure out what the decimal equivalents are. So this is 4.24-ish, and then 17.15-ish, just so I can understand what are my smallest, middle, and large sides. So the smallest is the 3 square root of 2. So if I do 3 square root of 2 plus 5, and I want to make sure that that is greater than 17.15, or 7 squared of 6. Let's write it like that. 7 squared of 6. Remember, I changed those to decimals. So 3 squared of 2 is 4.24 plus 5. Is that greater than 17.15? It is not. This is false. That would be 9.24. False statement. So this is not a triangle. So you do not then classify it. Not a triangle. Don't worry about classifying. Let's look at the you try now number 3. It says, does the triangle in the diagram form perpendicular? I wish it would be segments. And essentially, we are just seeing if it is a right triangle. So the question is really, is this a right triangle? Even though the picture looks like it, we need to verify it. So we're going to take our 6 and our 9. Although 3 square root of 13, let's figure out what that decimal equivalent is. 3 square root of 13. I just want to make sure it's bigger. 10.816. Okay, we're good. So this is definitely the longest side, which is the hypotenuse. So if I do a 6 squared plus 9 squared, and then I'm going to do a box, and then I'm going to put in parentheses 3 squared of 13 squared. 6 squared is 36, 9 squared is 81, And then 3 square root of 13 quantity squared is going to be, I think, 117. And then this is also 117. So the left and the right hand are the same. Therefore, because we have equals, I can classify that as a right triangle. Yes, indeed. So I know it's a triangle. I am going to say that this is a right triangle. And to answer the question, does a triangle form perpendicular segments? So I'm going to say it's a right triangle. So yes, the legs are perpendicular. Okay? All right, let's do, you have an answer already for number 1. You could try that on your own. Last one I'm going to finish up with is question B. This one's a little bit longer, so I'm going to plot the points, -1, -1. That's x. 0 up 4 is y. To the right 6, I go off the page and up 2. So I have this on a grid. I can connect these 3 points, and it says graph the points and then classify. So we're already working under the assumption that it, yes, is a triangle. Now we just need to classify. In order to do that, this is where we bring in some old information. We need to use our distance formula. And our distance formula between any 2 points is the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. I'm going to find the distance between all of these segments. So I'm going to do xy, I am going to do yz, and I am going to do zx. When I do the distance formula, I'm going to keep my square root symbol for my answer. I'm not going to simplify it, and I'm not going to approximate it. So first, let's figure out the distance between x and y. When I do the distance between x and y, I'm going to focus on 4 minus a -1 means 4 plus 1 or 5 squared. Then I'm also going to do 0 minus -1 means 1, and I need to square that. So xy is the square root of 26. I'm going to put that over here. I'm going to do the same thing for yz and then just write the answer down for the other one. So yz, I'm going to do 2 minus 4, which is -2. And then -2 squared is 4. So I'm doing yz. And when I do that, remember I'm doing 2 minus 4 quantity squared is -2 squared, which is a 4. So let's do -2 squared. Then I'm going to do the same thing with 6 minus 0. So this is 6 squared. This will give me the square root of 4 plus 36. So the square root of 40 is yz. Then I would do the same thing with xz. I would subtract the x coordinates from each other, square it, then subtract the y coordinates from each other, square it. So, excuse me, xz is square root of 58. No, I'm not simplifying or approximating. What I need to do now is, notice how these numbers are 26, 40, 58. So to see or to classify, I'm going to write the word classify. I am going to do square root of 26 squared plus the square root of 40 squared. How does that compare to the square root of 58 squared? When you square square root, you remove the symbols. So this is saying 26 plus 40. How does that compare to 58? When I fill in the box, 26 plus 40 is, 26 plus 40 is greater than 58 because 26 plus 40 is 66. Because we have greater, it will be acute. So this is an acute triangle. It looks like an acute triangle, but you need to verify that with the formulas and this converse of the Pythagorean theorem. Now you are ready to go. You can try the other you try now if you want and check your answer at the bottom.